Hello everybody. Now we are going to see the notch distribution law. As we have discussed in the earlier lecture, that solvent extraction is the extraction of inorganic substance from aqueous phase to the organic phase. So, according to notch distribution law, when a solid distributes itself between two solvents that are immiscible with each other, the ratio of concentration of solute in the two solvent remains constant, provided the temperature is constant and the solute has the same molecular condition in both the solvents. Okay, so if water is there and we can say ethyl acetate is there, or we can say petrol is there, half liter of water and half liter of petrol is there. So if any organic substance we pour in the water and that is soluble with the water, okay, so what will happen? Now, some of the amount of substance will remain in the water and some amount will go into the petrol. Okay, now both are the together. That petrol and water are the together. Okay, what will happen? So the ratio of concentration of that particular solute or substance in the water and the petrol will remain constant provided that temperature is constant. Okay, and the molecular conditions are same in both the phases. So these are the two conditions over here. What happens? See here, if C1 and C2 are the concentration of solute in two immiscible solvent, okay, then the ratio of two remains constant. That means the ratio is known as a partition coefficient. That is called partition coefficient. What is that is given by KD. Okay, so C1 is the concentration in phase 1, C2 is the concentration of solute in phase 2. Okay, what happens? Most of the time, the molecular conditions are not remain same in both the phases. Okay, so in aqueous phase, that may be there may be the formation of dimer or trimer like that. Okay, or the reverse condition in organic phase, that is also possible. So if the molecular conditions are not remain same, then the term partition coefficient is defined in a different way. That is, it is called then as a distribution ratio. It is denoted by capital D. Okay. So in this case, what we say, the total concentration of solute in the solvent 1 and total concentration of solute in solvent 2. Okay. So total concentration in aqueous phase to the total ratio upon total concentration in organic phase. Okay, if solute has the same molecular condition in both the solvent, in that case only we can say partition coefficient and distribution ratio are the equal. Partition coefficient and distribution ratio are the equal. But if the molecular conditions are not remaining same, then the term we are going to define here as a distribution ratio. Now we are going to see the expression for distribution coefficient. We are going to see expression for distribution coefficient. For that, we are considering here, see what, let capital W be the amount of solute present in the aqueous phase, म्हणजे पाण्यामध्ये आहे असं समजा W gram. Then VW is the volume of aqueous phase, पाण्याचं volume VW आहे असं म्हणूया. Then VO will be the volume of organic phase, हे समजा पेट्रोलचं volume आहे असं समजा. That I just given as an example in previous slide. And W1 be the amount of solute remain unextracted at the equilibrium after first extraction. Okay, so W1 will be the amount of solute remains in the water after first extraction. Okay, I think it is clear to you. Now, the amount extracted will be total amount minus W1. So this will be the amount extracted that can come in the petrol. Okay, then concentration of solute in aqueous phase. Aqueous phase मध्ये काय कॉन्सन्ट्रेशन त्याचं aqueous phase मध्ये किती राहिलाय तो आता ह्या मोमेंटला W1 ग्राम राहिलेला आहे. aqueous phase चा टोटल व्हॉल्यूम काय आहे VW आहे. So W1 upon VW will be the concentration of solute in aqueous phase. Similarly, concentration in organic phase will be the W minus W1, which is extracted after first extraction upon volume of total organic phase. This is what the concentration. Then next is the distribution ratio is given by concentration in or aqueous phase to the concentration in organic phase, or concentration in organic phase to the concentration in aqueous phase. Okay, see here what they are giving here: concentration in organic phase to the concentration in aqueous phase. So rearranging above equation, we get this equation. Okay, if we solve this equation, if this after arranging, it gives a D. Okay, so after solving this, you will get here W1. W1 is equal to VW upon dV0 plus VW in square bracket and then W. Okay, now divide this equation by VW. Divide this equation by VW. What you will get here now? VW upon VW will be the 1. VW upon VW will be the 1. Okay, and VO upon VW is the X. What is the X? X is the VW upon VO upon VW, is the ratio of volume of organic solvent to the volume of water. Organic solvent to the water. Okay, this is what the X. Okay, so this is what the equation is. Okay, so this is the amount of substance remain unextracted after first extraction. After first extraction, right? Now see, conditions for extraction. First is the distribution ratio. It is expected that distribution ratio should favor the organic phase, so that maximum amount of your solute, which was present in the water or which was present in the aqueous phase, that will come into the organic phase. This is what the first expectation in the distribution ratio. Then time of equilibration. The time of equilibration is just the time required for the two phases to get separated from each other. Once they are shaken or vigorously mixed with each other and they are allowed to stand for 1 or 2 minutes, they will quickly get separated from each other, because as we know that की पाणी आणि पेट्रोल हे पूर्णपणे मिक्स होऊन तसंच राहू शकत नाही. दोन फेजेस हे एकमेकांपासून सेपरेट होतात, राईट. आणि अशा पद्धतीने ते काय होणार आहे त्या ठिकाणी टाइम ऑफ इक्विलिब्रेशन यू कॅन डिफाइन. Then volume of solvent. Volume of solvent. So from the formula itself, you can see that as the volume of solvent increases, then amount of extraction also increases. Amount of extraction also increases. Okay, so this is what the ratio X. Okay, we know that ratio X is VO upon VW, right? Now see what happened here. But it is observed that instead of giving only one washing with 1 liter of solvent, it is better to separate that 1 liter of organic solvent into 4 part or 5 part, and then we should proceed for the extraction by all the 5 parts, one by one. म्हणजे 250 ml 4 पार्ट केले 1 लिटरचे. पेट्रोल समजा 1 लिटर आहे आणि पाणी जे अर्धा लिटर आहे, तर पेट्रोलचे 4 पार्ट करा 250 ml चे, आणि पहिल्या पार्टने वॉशिंग द्या ऍक्वेस फेजला, तो ऑर्गॅनिक फेज सेपरेट करून घ्या. पुन्हा दुसरा 250 ml पेट्रोल घ्या, त्याच्याने पाण्याला वॉशिंग करा, म्हणजे पाण्याबरोबर शेक करा, मग पेट्रोल त्यातलं ते सेपरेट करा. पुन्हा तिसरं घ्या, त्याच्यामध्ये पुन्हा ते सेपरेट करा, आणि चौथं घ्या. सो दिस इज व्हॉट द मल्टिपल वॉशिंग. दिस इज व्हॉट मल्टिपल वॉशिंग, और I can say here as a multiple extraction. In this case, we should say as a multiple extraction. Okay, so n will be the value of number of extraction. Value of number of extraction. So see what happened. This is what the equation W1 is equal to 1 upon n dx plus 1. As I told you, n is the number of extraction. Okay, and the Vn for the n of the means volume remain that amount of solute remain unextracted after n washing or n extraction will be the W dash n is equal to 1 upon dx plus 1 raised to here square bracket raised to 1 raised to n into W. So divide above equation by this equation, what you will get W1 upon Wn or W dash n is equal to dx plus 1 bracket raised to n upon 1 plus n dx. Here it is observed that W1 is far greater than W dash n, because the numerator will be containing more number of terms. Okay, this indicates that W1, that is amount remain unextracted after one extraction, is having more quantity than the amount remain unextracted after N extract means what? If you use 1 liter of petrol for a single washing, and if you use 250 ml into 4, 250 ml into 4. Okay, this is also 1 liter, but you are using 1 liter for 4 times. Okay, this is also 1 liter. So this will give you the better extraction. है ना? म्हणजे आपण काय करतो, तुमच्याकडे बादलीभर पाणी आहे, त्याच्यामध्ये भांडे धुतले, ओके, आणि ती बादली हाफ हाफ केली, आणि पहिल्या हाफ मध्ये पाणी भांडे धुतले आणि दुसऱ्या हाफ मध्ये पुन्हा ते भांडे धुवून आपण ठेवलं, त्याला काय म्हणतो मल्टिपल वॉशिंग. तसं इथं मल्टिपल एक्सट्रॅक्शन आहे. मल्टिपल एक्सट्रॅक्शन मध्ये जास्तीत जास्त जो सोल्यूट आहे तो काय होतो, एक्स्ट्रॅक्ट होतो. दिस इज व्हॉट द बेनिफिट ऑफ मल्टिपल extraction. Okay, now what is the effect of temperature? We know that as the temperature increases, definitely solubility of solid in the solvent is increasing. Okay, and for that sake, it is observed that the solubility should be in the favor of organic solvent, so that we will get a more efficient extraction over there. Okay, so this is what the whole motto behind all these factors and the you know all the terms which we are learning here. pH also plays very important role here. Remember here that the pH of the aqueous field should be such that as like the nature of solute. If your solute is acidic in nature, then extract that solute, pH of water should be maintained acidic. If your solute which is present in the water or aqueous phase, that is basic in nature, so to extract that solute from the water into the organic phase, we have to make the pH of that aqueous phase as a basic pH. Okay, then only it is possible to extract that the solute from aqueous phase to the organic phase. Okay, so this is very important. Okay, and hence pH also plays very important role. So this explanation is regarding that over here, and one or two examples they are giving as a chelating agents. Okay, they are like they are acidic in nature, hence we need to maintain the aqueous pH as acidic, and then only we can extract the metal chelate from the aqueous phase. Okay, so pH 112 is an important concept introduced for the extraction. It is defined as the pH at which 80% of the extraction is happening over there. 80% of the extraction is possible over there. Okay, so that is very important concept. Okay, after this there is a efficiency of extraction. So this is one more concept which we are going to learn. After efficiency of extraction, we are going to see the percentage extraction, then after that multiple extraction, how it works. Okay, after that examples are there. Okay, and after that we are going to see the types of solvent extraction. Okay, then we will proceed for the chromatography. Okay, so for this lecture, this is enough. In the next lecture, we'll continue with the efficiency of extraction. Thank you.